Question 12. Which volume of carbon dioxide gas at room temperature and pressure is produced when 2.65 grams of sodium carbonate reacts with 100 cm³ of 0.1 mole per dm cube hydrochloric acid? The chemical equation for this reaction involves the first reactant, sodium carbonate, and the second reactant, hydrochloric acid. This is a carbonate acid reaction which will allow us to form a salt of sodium chloride and two byproducts of carbon dioxide and water. Balancing this equation out, we should get 1 mole of sodium carbonate reacting with 2 moles of hydrochloric acid to give us 2 moles of the salt product, 1 mole of carbon dioxide and 1 mole of water formed. The amount of each reagent used is given to us in terms of mass for sodium carbonate and volume of this specific concentration of the acid used. We need to first find out which reactant is in excess, because the amount of carbon dioxide gas formed is going to be dependent on the amount of limiting reagent that has been reacted. To compare the amount of the two reactants, we need to compare it fairly based on the number of moles of each reactant. So the number of moles of the first reactant can be found by taking mass over the molecular mass of this compound, which is 23 times 2 plus 12 for a carbon and 3 oxygen atoms, giving us about 0.025 moles of the first reactant that is available. To find the number of moles of the acid used, we need to multiply the concentration of the acid used by the volume used, taking into account the change in units from cm³ to dm³ by dividing it by 1000, which will give us 0.01 moles of hydrochloric acid used. The mole ratio of the first reactant to the second is 1:2, which means if 0.025 moles of the first reactant is reacting, there should be 2 times of this amount of the acid present to react, which will be 0.05 moles of the acid. However, in this question, there is only 0.01 mole of acid available, which means that the acid reactant is going to be the limiting reagent. Therefore, the amount of products produced will only be dependent on the amount of limiting reagent available, which is 0.01 moles of hydrochloric acid. Since the ratio of the acid to the carbon dioxide product is 2:1, it means that the number of moles of carbon dioxide produced is half of 0.01 mole, which is 0.005 moles of carbon dioxide gas produced. The answer options are all in terms of volume in cm³. So in order to convert the number of moles to volume, we need to make use of the formula, knowing that 24 dm³ is the volume occupied by 1 mole of the gaseous substance. Therefore, 0.005 moles of CO2 now will occupy 0.005 multiplied by 24 dm³, which will give us 0.12 dm³ of space occupied. Converting this to cm³, we need to multiply it by 1000, and that will give us 120 cm³, leaving A as the correct answer.